In this episode, we are going to talk about the geometric mean, which involves grouped data. So, in the random discrete variables, we obtained a logarithm formula for the geometric mean. So, we saw that the geometric mean is equal to the antilog of 1 over n summation of all the x starting from I to 1 to the m this way. So this formula was obtained for the random discrete variables where our n represents the number of occurrences. Are we okay? So here we are going to talk about grouped data. And we know that for group data, we are going to have the frequency and midpoint. Are we okay? So here there's going to be an interval. There's going to be an interval for a class interval. Therefore, we will need a midpoint, and this midpoint will be named as our x for us to be able to derive the formula. So we are also going to have a frequency for group data. We call it our f. So in such instances, our geometric mean, GM, for group data is very simple. That's why I said we have to pay attention to this formula from the random discrete variable video. So here we are just going to modify the formula where we are going to have the antilog of, now this is going to be summation from I 1 to n fi. Sorry, this formula we still have logarithm inside. Are you okay? We still have log inside. So this will be the logarithm of x, log x I. So this is going to be f, which is the frequency multiplying the logarithm of x I. Everything is also on the summation of f. So this is the formula. So here we are just replacing n, where our n is just equal to the summation of what? The frequency. So instead of us just finding the summation of the log x, we are going to find the summation of the frequency multiplying the log x. So let's assume for a table we have the class where we have our frequency and our midpoint x. We're also going to have log x and our final f log x. So this is what the table is going to look like. This part 4. So we are going to have a class, say from A to B, C to D, E to F for the class. Frequency, let's call this as alpha, beta, and gamma. Our x, which is going to be the midpoint of alpha A plus B on 2, that is also going to be C plus D on 2, and E plus F on 2. So let's say the midpoint 2, we are getting theta, we are also getting V, and we are getting C. Or let's say the sign over here. Now we are going to find log of this midpoint and get the answer written over here. Are we okay? So whatever we have for the log of the x, we are going to multiply this by that to put the answer right here, right here. So after that, we are going to sum everything here, which is f log x, and we will bring it back into the formula as antilog of summation I to n, which is f log x. This whole f log x is what we are obtaining here. Are we okay? So that's the summation. This sign is just the summation, and everything is going to be, the antilog is going to affect everything here. So this is not everything is going to be over summation of f, which is summation of this frequency. So very simple. You have to just pay attention to the formula, get them right. Let's solve one example under the group data to see how we can go by this. Example: calculate the geometric mean of the data below. So we have mass in kilogram of people, and they are into class of 55 to 59, 60 to 64. We also have 65 to 69, 70 to 74, 75 to 79, 80 to 84, and we have to find the geometric mean. You can only do this when you know the formula to find the geometric mean. So straight away you write down your formula for group data, that your geometric mean is going to be the antilog. This will help you to continue the table and the parameters to add. It is going to be the antilog of summation of the frequency I multiplying log x of I, everything on summation of f, this way. Are you okay? So looking at the table, we need x. This is a group data, meaning our x, which is going to be the midpoint of the classes. So midpoint, and that will be x. So when you take the first class from 55 to 59, you find the midpoint, and 60 to 64, the midpoint, we also find for all the other classes. After getting x, we will need log x. We will need log of the x also as one column. So the formula is helping you to fish out whatever parameter you will need. Are you okay? So after getting log x, we are going to now multiply or do a multiplication of log x and the frequency. So the next column is going to be f multiplying log x. So that will be for all. So that whatever we get at this column will be the summation of f log x. We just put it there over the summation of the frequency. Are we okay? So this is our final table. So straight away, what is the midpoint of 55? And so we know that the x, which is the midpoint, is going to be the upper boundary plus the lower boundary. So they are all boundary, everything on 2. So 55 plus 59 on 2, that is going to give you 57. This is also going to give you 62. This is giving you 67. We have 72, 77. You can pause the video and check for all the details. So this is the midpoint of all the classes. So this is our x. Now we are going to find log x, which is going to be log of the x, which is 57. Are we okay? So this is going to give us 1.7559. This is giving us 1 point. Always write it to 4 decimal places for the log. 7924. This is giving us 1.8261, and 72 is also 1.8573. This is giving us 1.8865, 1.9138. So this is the log of the x values. Are we okay? So now let's multiply the frequency f by the log x. So that is going to be 3 multiplying 1.75 59, and that is going to give us 5.26. Please pay attention so that you don't multiply the x by this. This is wrong. It is rather the f multiplying the log x. So this is going to give us 0.2677. This is going to be 16.1316. This is going to be 21.9132. This is 13.0011. This is also going to give us 9.4325, 7.6552. Are we okay? So we have all the parameters in place. So we have to find the summation of f log x. Are we okay? Let's look at how we can find that, because in the formula we are interested in f log x. This will sum up to 73.4013. We also need summation of the frequency, summation of f, which will give us 40. Are we okay? So now from the formula, our GM is going to be antilog of, now summation of f log x. That's what we are getting at 73.4013, and summation of f, which is 40, this way. So this is antilog. This whole thing is giving us 1.8350. So your antilog, which is GM, is going to give you 10 to the power 1.8350. And our geometric mean is going to be 68.396. So with the data given, this is our geometric mean. Are we okay? We can solve one more example to see how we can find the geometric mean. Let's take the next example. Example 2. The following is the distribution of marks obtained by 109 students in a subject in an institution. Find the geometric mean. Once you see the table, you can see the interval, meaning this is a group data. So you recall your formula for group data, the formula to find the geometric mean, where we saw that our GM is giving us antilog of summation of f log x on summation of f, this way. So this will help us to find our parameters to add to the table. Are we okay? So straight away we have our f, we will need x, we will need log x before we find f log x. So the midpoint of the class will be our x. So we have that column created. We will also have another column which will be log of the x that we are going to have. That column will be created before we get the frequency multiplying the log x. That column will also be created this way. So once you know your formula, it helps you to fish out the information needed to fill your table. Are you okay? So you have to pay attention and fill it. So the midpoint, the first class is 4 to 8. So that's going to be 4 plus 8. That is going to give us our 12. Are we okay? Then we divide our 12 into 2. That is going to be 6. So I'm going to fill this part. We are going to have 6. And we are going to have this part as 10, because 8 plus 12, that is 20, by 2, that is going to be 10. And we are going to have this as 14. This is also going to give us 18. Now we have 22. We are going to see also here as 26. Are you seeing a pattern in the values? Yes. So after 26, we are going to have 30. And this is also going to give us 34. This is going to give us 38. Are we okay? So these are the x values. We take logarithm of the x values. So log of 6, that is going to give us 0.24 decimal places, 7781. This is going to be log to the base 10 of 10, that is going to be 1. So 1.0000. Log of 14, and we are going to get our value as 1.1461. Log of 18, that is going to be 1.2552. Sorry, yeah, we have log of 22. So log of 22, we are also going to get 1.3424. Log of 26, that is 1.4149. Log of 30, 1.4771. Then log of 34, 1.4. That is going to be 1.5. So let's write it well. You have to pay attention to all these details, because as you make mistakes, your answer is going to be altered. 1.4. So this log of 38, that is going to give us 1.5797. Are we okay? So now what we have to do is multiply the frequency by the log x. Once you know what to do, and once you get your table, the rest is history. It becomes so easy. So now the frequency 6 by 0. This, that is going to give us 4.6686. We are going to get 10 by 1, which is 10. We are going to get here 20.6298, 37.6560. We are also going to get 20.1360, 16.9788, 14.771, 9.1884, 3.1594 as our values. Are we okay? So now GM, antilog, summation of f log x on summation of f. So when we come to the table, f, summation of f, this should give you 109, because in the question it was stated that 109 students. So the frequency should go with the number of students. Now we also need f log x. So here is summation of f log x, and this summation is going to give you 137.188. Are we okay? So meaning my geometric mean is going to be antilog. Don't forget, antilog is easily forgotten by many people. So this is going to be 137.188 on the antilog of summation of f, 109. This is antilog of 1.2586, and this is going to give you 18.1387. Are we okay? This is our geometric mean. So once you go through the approach and know your formula, you'll be able to come out successful. Thank you for watching the episode. We had 2 examples. You can work on them and several other examples. In the next episode, we'll talk about another form of mean, which is the harmonic mean, both the random discrete variables and the group data. Thank you for watching this episode. Subscribe to the channel, like, and drop your comments.